Okay, welcome to chapter 6, take 2. This is 6.1. Today we're going to cover the standard normal distribution. We're also going to talk about normal distributions as well. So normal distribution is the most common of the distribution, and it's also the one that's used the most. We see this bell curve all the time in all kinds of disciplines. So let's say, for example, if we were to ask everyone at Cerritos College their shoe size, we would see that we would get all their data, and it would ultimately look like a bell, because everybody with the average shoe sizes would be built up here, and then you would get less people, and then we get people with very tiny feet over here, and people with very large feet would be on this end of the spectrum. So there are two parameters for the normal distribution. You have the mean, represented by the symbol mu, and the standard deviation, which is sigma. Okay, so we usually write this as x tilde, the little wiggly line, and for normal distribution, parenthesis, mu, comma, sigma. Okay, so the function, remember we talked about the probability density function, which tells us, area underneath the curve is the probability and all that. For the normal curve, it's very complicated, so we don't really need to memorize it. This isn't calculus. So one thing that we do want to say about it, though, is about the normal distribution, is that it's a symmetric curve. There's symmetry. The mean is usually the same as the median because it's symmetric. However, if we change the mean, if we change the standard deviation, the curve also changes. Okay, so the whole area is equal to 1. Now, if we change the standard deviation, it changes the shape. So if the standard deviation is large, then the curve widens, right? And if it's smaller, the standard deviation is smaller, the curve gets more thin. It changes shape. It gets more thin. It looks more this way. So if it's thin, it gets like this, and if it's wider, if standard deviation was to become wider, then it would be longer. Sorry, this is kind of actually already the way it was, but it'll be something like this. And let's say this was the center. And moving the mean changes it to go to the left or right. So that causes a shift, okay? So that means there's infinitely many normal probability distributions, and one we're going to focus on is standard normal. So standard normal, so the normal curve, it's very old. It comes from 1733. It was developed in 1733, and it didn't really come to light until later, in 1924 by Pearson, okay? And Gauss is actually who made it popular. He used a normal curve to analyze data, astronomical data, and then often the normal curve is called the Gaussian distribution. Okay, so what is a standard normal distribution? So all you need to know about the standard normal, it has to do with z-scores. So if I take all the data in a regular normal distribution and I standardize it, meaning that I convert every single value into a z-score, I get a standard normal distribution, okay? So here, let's suppose you have the mean of a normal distribution is 5 and the standard deviation is 2. So how far away is the value 11? Well, 5 plus what is 11? 6. How many standard deviations is 6? Well, if standard deviation is 2, then 3 times 2 is 6. So we have three standard deviations away from the mean is what 11 is. So we say that the z-score is 3. Remember that the z-score is the number of standard deviations a value is away from the mean, okay? So think of it like kind of a z-score is a way of saying, okay, this value is 3 standard deviations to the right of the mean. This value is -3. It's 3 standard deviations to the left. Okay, and here's the formula, and I believe we went over this already, but if we take all the data and we change it to z-scores, we produce this distribution, and it's called the standard normal. And we use the z because they're all z-scores. And the mean will always be 0, and the deviation is 1. That's by design. You did that by putting them all in this, converting them to z-scores. So you have something that looks like this. The mean is at 0, and the distribution, the standard deviation is 1. All right, so let's do a super fun example. So if you have x equals 1, and you have a normal distribution with a mean of 12 and a standard deviation of 3, can I find the z-score? Well, yes, you can. You just plug it into this equation here. You have x is 1, mean is 12, standard deviation is 3, so 1 minus 12 over 3 gives you a negative 3.67. So the value of the z-score of x is negative 3.67. That means that 1 is 3.67 standard deviations away from 12. Okay, so let's do another fun example. Suppose that doctors believe a person can lose 5 pounds on the average, that's a hint right there, on the average, in a month by reducing her fat intake and exercising consistently. And let's suppose that this weight loss has a normal distribution. So let x be the amount of weight lost in pounds, and let's use a standard deviation of 2 pounds. So that means that x is normally distributed with a mean of 5 and a standard deviation of 2. Okay, so let's fill in the blanks. Okay, so suppose a person lost 10 pounds in a month. So what that means, remember that x is the amount of weight lost, so that means that x is 10 positive. Okay, so what is the z-score for that? We need to use this equation, right? Do we have all the things to solve for z? Well, we have x, we have the average, which is 5, and we have the standard deviation, which is 2. So that's all you need to know. You plug that in and you get z. Okay, so the z-score will be 2.5 because 10 minus 5 is 5. 5 divided by 2 is 2.5. So since it's positive, that means that x equals 10 is 2.5 standard deviations to the right of the mean 5. Okay? All right, let's do another one. So suppose a person gained 3 pounds, which is negative, right? Then what would x be? What would z be? So if this is a negative weight loss, right? Gaining is a negative weight loss. That means that x is equal to negative 3, right? So if x is equal to negative 3, how do we find the corresponding z-score? You guessed it, we plug it into the formula, right? So negative 3 minus 5 over 2. So negative 3 minus 5 is negative 8. Negative 8 divided by 2 is negative 4. Okay? And then what does that mean? That means that when you say negative 4, that just tells you that x equals negative 3 is 4. Notice that this is positive because it's an amount. Okay? 4 standard deviations. And then here's where the negative comes in. Because it's negative, we say it's left of the mean. Okay? Because it's negative. All right. So one more time. So then here we have the same situation, and now this is different. So we have 2 different distributions here. We have x is normally distributed with 5 and a standard deviation of 6. And we have y is normally distributed with a mean of 2 and a standard deviation of 1. And they ask, if y is 4, what is z? So if y is 4, we're only going to use this one because it's for y, okay? Deals with the variable y. And we just plug it into the equation. So z is equal to, and the data value is y, so 4, minus the mu, which is 2 here, all over sigma, which is 1. So 4 minus 2 over 1 is just equal to 2, where you have 4, mu is 2, and sigma is 1. All right, now let's talk about the empirical rule. What is the empirical rule? So now that we're talking about data, this is kind of how a normal distribution works. You have the mean in the middle, you have 1 standard deviation to the right, 2, and then 3, negative 1 standard deviation, 2, and then 3. So what is the empirical rule? Okay, so let's suppose you have a normal distribution. This is saying this, okay? It's kind of like, where is most of your data? Okay, so let's start with 68%. 68% of the values are within 1 standard deviation of the mean. So here's your mean, and here's the standard deviation. It's 1 to the right and 1 to the left. So basically all this that I'm highlighting, oops, forget the one that I messed up right there, but all of this area right here contains 68% of the data, okay? Which makes sense, right? Because this is kind of like a big piece, it's more than half. Okay, so so there you go. 68% of the data is in there. Oops. Oh, I erased that again. Great. Okay, so all of this here is 68%, just in here, right? Because this is within 1 standard deviation, just here. Now, what about 95% of the data? So let's see, 95% of the values, it's supposed to be blue, it looks like purple, is within 2 standard deviations of the mean. So here is where 95% of the data is. All of this here, okay? So that's 95. 99.7%, so almost the rest of the entire data. So here, from -3 standard deviations from the mean to +3 standard deviations from the mean is where 99.7% of the data lie, okay? And that's the empirical rule for normal distributions. So again, right, so 68% of the data is here between 1 standard deviation of the mean, and 95% is within 2, and then 99.7% is within 3. So, okay, so z-scores for +1 standard deviation and -1 is just 1 and -1, which makes sense because that's literally the definition of a z-score. How many standard deviations away from the mean am I? Okay, that number is your z-score. Okay, so the rest holds for 2 standard deviations and -2 standard deviations. So that's +2 -2, 3 standard deviations, and -3 standard deviations is +3 -3. Okay, so let's do a super fun example. Okay, so suppose you have X that has a normal distribution with mean 50 and standard deviation 6. Okay, so here that means that 68%, according to empirical rule, 68% of the X values lie within 1 standard deviation of the mean, right? So that's this distance, like this underneath the curve, right, from here to here. So from here to here, 68% of the values. So what is 1 standard deviation of the mean? So if our mean here is 50, right? That's right here, 50, that's our mean. In this particular case, our standard deviation is 6. So we add 6 and we subtract 6, okay? So if you add 6, right here, 56 is the upper, limit. And if you subtract 6, you get 44. So now, because of the empirical rule, I could say, well, most of my data is going to be contained from 44 to 56, okay? So that's it. So the z-score for 44 in this case is -1, and the z-score for 56 is +1. So the third case, where you have 99.7%, you just do 3 times the standard deviation, which is 18, add and subtract it to the mean. So then your upper value is going to be 68, and that's going to be over here, 68. Okay, 68. And then your lower value is going to be 32, because you're going to do 50 minus 18, which is 32, and that's over here, 32. So from here to here, all over here, is 99.7% of all your data, okay? Which makes sense because you see that it's 99.7% of the area underneath the curve anyway. All right, so that's empirical rule. And that is your super fun homework. Again, I'm sorry that the audio was off, but hopefully it's better now. And I will see you guys on the next video.